There we go. We're recording now. Whatever. So it's section 8.4 is exponential growth. So it's exponentials models is what it's called. Exponential models means we got exponential growth and decay. Do me a favor, close the blinds because I think it's is it kind of washed out?
Yeah.
Is that a little better? More better? Okay. All right, here we go. So the way this works is, if you read a little bit, it's talking about, these are just general differential equation solutions. That's exactly what I just turned in my homework on it all the way, but there's more to it. There's more than this, and it gets more complicated, but at least this is where we're going to start. Okay, so when you're doing exponential growth and decay, that's not this, that's that. It's not, it's the other computer misbehaving now. Hang on a second while we restart this stupid thing. I can't win. Okay, now I have to refocus it or that it will go away. I have to make it bigger and it froze. No, this is not.
So no notes.
Oh, no, I'll still give notes. It just won't be a video, and that just sucks. This is like not cool. Let me see if it's just not connected real well. Okay, so it focuses, and you make it bigger. We're not allowed to make it bigger. You stupid thing. One more time. And I'm not going to touch it this time. Hang on, watch this. There's more than one way to do this. You can put this down like this. Move it like this. Focus it. And I'm not touching it again. Okay, exponential growth and decay. So the words you'll see, so when you're looking at the words, there'll be some sort of the rate of change of y, substitute any variable you want, right? It can be any variable. It can be p, it can be t, it can be c, whatever variable they decide to put in there. And then sometimes they'll have with respect to, sometimes they won't. And then it'll be a with respect to. And we're going to say t in this case. If they don't have with respect to, if you look down there and they have points that are x, y's, or if they have values where it's p and t or n and t or whatever it is, whatever they decide, n and s, whatever variables they're using, and it'll be obvious by the points. The y, well, it's usually they usually use a capital letter. Whatever the capital letter is, they'll say like n, it's a rate of change of n, and then down below they'll have n and s. Then n is the y and s is the x. Okay, so s is the thing it's with respect to. You'll see what I'm talking about when I show you examples. And then they'll tell you that whatever it is proportional to y. There'll be some variation on that. So the first thing you do in every single one of these problems, and it's what I had to do in my homework, first you're going to write the differential equation. Oh, I can't spell today. And the way we abbreviate that in my class is just the DE. The DE is the differential equation. So for this one, what is the differential equation? What does rate of change of y with respect to t mean? What does that mean? Yes. So dy dt, the equal sign is proportional to y. What does that mean? ky. jk. Not really JK. It really is, it's KY. It's that simple. Boy, that's not too bad, is it? So that's your first step. Guess what your second step is? Solve the differential equation. To solve it, do we have to separate the variables and integrate both sides? So when I separate the variables, do I end up with 1 over y dy is equal to k dt? Is there any t on the right-hand side? No? What's the integral of dt? T plus c, right? So I'm going to integrate both sides. What's the integral of 1 over y dy? Natural log absolute value of y is equal to the integral of k dt is just kt plus c. We did one like this yesterday, remember? We translated these words. We did an exponential growth and decay problem like yesterday. Next, so all these steps, am I going to give you words and you're going to have to show me all these steps at least once on the test, right? And then after that, if I give you any more problems, you just have to, you can just, if you remember the equation, or after you just got the equation, you'll be able to use it, right? You only have to do it once. Okay, we want y by itself. How do we undo a natural log? So we're going to take the exponential function of both sides. I can't leave it like this. Do you need to show me this step I'm about to show you every flippin' time? I don't care if you know it yet. On this test, you have to show it. This equals e to the kt times e to the c. And what is e to the c? It's just a constant. Can I call it c? You can call it b, you can call it a. I like c. So this means if I undo the natural log here, I have y equals to c e to the kt, which you should know from chemistry or physics, or I lost the pen. We're going to give it a minute, and it's going to cooperate. There we go. It came back. Hurry. We need to hurry up and do this before it dies again. All right. So once you've solved for the differential equation, then you're going to use any information they give in the problem. So on those word problems we were doing, the ones where I was having you translate and then solve, you were actually doing this. Did you have to use the information given? So part 3 is you're going to use the given. You're given information. You're given that y is the, if it, so y is y naught at time equals 0, right? And they told you that y naught was, oh, hang on. I'm just doing a generic one. Sorry. So they'll give you an initial condition, and then we'll plug it in. So we'll say y naught is equal to c e to the 0 power, because why not? It makes it go to 1. Yes? Does that mean that y naught is equal to c? And even though you know that, do you have to show it? Do you have to show this step? Yes. I need to understand that you understand what you're doing and not just memorizing it for the moment, because y'all memorize it for the moment and you'll forget it the next moment, like after the test. Okay, once we find what c is, then can we put it in the equation and we get y equals c, right? So that's y naught, sorry. Y naught e to the kt. And then you're going to have to use another point that gives you the time, and you're going to find for k. So you have to be given two conditions. The initial condition helps you find c. Any other condition helps you find k. Unless I'm being wicked and I give you 2 points that are not initial condition, then you have a system of equations to solve. That will happen to you in college. If you're doing a STEM major and you have to do exponential growth and decay, you will have to do a system of equations. So far, all I've seen on the AP test is initial condition and something else. Okay, important things to know. Additional information for these kinds of problems. Half-life is a big deal. They expect you to know what that means. You should have all taken chemistry, at least one. You should have talked about half-life, right? Mm-hmm. Half-life means it's the time it takes hang on, for y to reduce to half of it. Half of y. So whatever time you are at, you start at. So the best way to do this is say, you start with some initial amount, and it's how much time it takes for you to get to half that initial amount. So let's see what that looks like. That means the 1/2 is equal to how much I started with, actually, how much I have over how much I started with. If I have half as much as I started with the ratio of how much I have now, so this is at any given time, is equal to the initial amount. If I do that, so that's e to the k, and this would be the half-life right here. That's the time. So whenever we're trying to find this, we will try to find this, you plug half in here and you undo everything. You have to know the k already. So you had to have already found the k. But the k is the same every time. Suppose they give you the half-life. They'll give you the half-life, then it's even easier, because if you have this, you know this ratio is a half. You have to know that. If they give you the half-life, then the ratio of how much I have now to how much I started with is a half, right, at that time. So what we do is, so that's half. Do I have to undo this? So am I going to do natural log absolute value, let's just a parentheses, a half, it's positive, is equal to natural log of e, I undo it, and it's just k t, sorry, half-life. Half-life. We have this. And if I want k, is k every single time, I'm going to change to black. K is equal to natural log of 1/2, and we'll talk about that in just a second, over the half-life every single time. Now, yeah, so basically, can we simplify that? Because I have a ratio, right? We're going to expand it back out. Is that equal to natural log of 1 minus natural log of 2 over t to the 1/2? What is the natural log of 0? I mean, sorry, natural log of 1, I was getting it wrong. It goes to 0, right? So what's going to happen is every single time is going to be negative natural log of 2 over the half-life. Sorry, t 1/2. So if they want you to find the proportionality constant and they give you the half-life, this, you could go straight here if you remembered it. But can you use math to get there? Because I don't know about you, but I really get tired of memorizing new things. And do you have to be able to do this math backwards and forwards and upside down? Anyway, is this the same thing we did yesterday when we were finding the time, or we were finding the proportionality constant? Yes. Okay, final equation is y equals the initial amount e to the, well, it's the negative natural log of 2 over the half-life times time. That's k, right? Let me make that bigger and rewrite it because that's kind of messy. Time 1/2, that's a half-life, that's k t. Well, if we write this in terms of C for concentration, they'll say the C, the concentration at any given time, is equal to the initial concentration e to the, they'll either write it that way, sometimes they'll just write natural log of 1/2 over t 1/2 times t, and you just have to plug everything in. Huh? I didn't make it negative because I put a half in. I need you to get used to seeing it. They often will write it like that. Does it mean the same as that? You just be comfortable either way. Is this true for any half-life problem? Any half, oh God, it's just going to be one of those days. I think these were really bad batteries that I bought, apparently, because they're dying. Any half-life problem. All right, now we're ready to work an example. I think I'm running. Oh, I can start it here. Okay, so example 1. And you're looking on your little sheet. And example 1 for growth and decay is talking about we got a certain population in 1900 of a city is 50,000. In 1950, the population was 100,000. If the rate of increase of the population is proportional to the population, the rate of change is proportional to the thing, that's exponential growth and decay. And since it went up, it's growth, right? By the way, I should tell you that right now. Let me erase this. Really fast, if k is greater than 1, you have growth. If k is less than 1, you have decay. Makes sense? Because what does the exponential look like when it's negative? It goes down. Or is up, right? Reflected across the x-axis. That makes sense? Here, let me draw you a picture really fast. So, if it's positive, does the graph look like that? Is this the exponential? And if it's negative, if you do of a negative power, so it's 1 over it, right? Does it go down? Like so. Right? K is positive, K is negative. All right, you'll have to play with that. Next page, we'll start the example. I really wanted to go to the next page anyway. All right, example 1. Okay, here's the trick. You don't want to use 1900 and 1950, do you? Those are kind of big numbers. We're going to say 1900, the year 1900 is time equal to 0. We're going to say 1950 is time equal to 50. Isn't that clever of me? Makes the numbers much more better. Yeah, that's why I teach math. So what is the population here? I'm going to say P is equal to 50,000. So P naught, not peanut. That's what my grandfather always called me. Oh, sorry. Oh, come on. No, you can't, no. P of 50 equals 100,000. So what do we do? What's the first thing we do with an exponential growth and decay problem? Write it. What is it? What's the differential equation? I need the DE. What is it? Okay, in this case we're going to call it P for population. Notice I called it P. Right? dP dt is equal to what? KP. What's my next step? Solve it. Is this going to be the integral of 1 over P dP equals the integral of K dt? Yes? Sure. Right? Yes? Okay, let's solve it. What's the integral of 1 over P? Natural log absolute value of P equals KT plus C. How do I undo natural log? Still exponential both sides. What do I expect to see here? You may write it e to the c, e to the kt equals c e to the kt. But do I need to see this? I need to see that you know that it was the sum of two things as a power. You busted it up and it's a product, and you called the e to the constant just a constant. Do I need to see all of that every single time that you're actually solving? All right, where did we get to then? What's our final answer? It is P of t equals c e to the kt. Okay, we got the general equation. That's called the general equation. Once we have the general equation, can we give it, were we given 2 points? Were we given an initial value? Did we force that to be initial value to make our math easier? Wasn't that clever? We have initial values. That's how we're going to find C. And do we have some point in the future we can use to find K? All right, just to go through this to make sure you all got it. If I know that P of 0 is equal to 50,000, then I know 50,000 is equal to C e to the 0, because K times 0 is just 0. That means C is equal to 50,000. So P of T equals 50,000 e to the kt. Now we got to find k. Can we use that at a point? Right? Right? Yes. All right, I'm probably not going to have enough room. Let's go to the next page. So I got to P of T equals 50,000, which was my C, and that use that initial condition to find it, e to the kt. I'm going to use my other one, which is 100,000, right? Is that my other point? How many years was that? So it's e to the k times 50. Divide by 50,000, do you have 1/2? Oh, sorry, 2. Doing it the other way. 2 e to the k times 50, right? Or so 50k. How do I undo an exponential? So I get natural log of 2 equals e, not e, 50k. How do I find k? K is equal to natural log of 2 over 50. By the way, no, never mind. Almost there. So what's my final equation? P of T is equal to 50,000 e to the natural log of 2 over 50 t. There are other ways to write this, but we'll just stick to the basics. This is a particular solution. This isn't a big deal. Particular solution. If they ask you for the particular solution, is that what they're looking for? If they say solve, that's what they're looking for. If they ask you to go use this, which is what they do, right? What will the population be in 2003? And what year would the population be 300,000? Do we have to use this equation to go answer those questions? That's my particular solution. I'm going to use it to answer the questions. So actually, that was not A, B, and C. Those were our steps 1 and 2 and 3 or whatever. So now we're going to actually do, we got to do their part A. Their part A says, I want to 2003. How many years in 2003, how many years after 1900 is that? 103, yes? This is the easy version. Sorry, I don't know why I wrote 8. 3. So P of 103 is equal to this equation with 3 plugged in. 50,000 e to the natural log of 2 over 50 times 103. And that is about 208,493, and I can't remember which way I rounded on this. I can't remember if I rounded up or down. Doesn't really matter. It's a whole number, right? We don't put part peoples. We don't have a quarter of a person. That's not pretty. No matter what game y'all play on. I don't know. Okay, what's the next part? Actually, that's part A. Part B. What's part B? I want to know when P of T is 300,000. 300,000, that's P of T some future time, is 50,000 e to the natural log of 2 over 50, right, that was my k, times t. Am I solving for t now? Guess what? It's all the same math, isn't it? Did you see that it's all, if you're finding k or t, is it the same math? So there's no excuse for you not being able to solve for those. And am I going to make you do this? Yes, because I want you to be able to do this math. Ready? Divide by 50,000. Okay, and it's really easy for those with no number sense. Cross that out, cross that out, cross that out, cross that out. What is 30 divided by 5? So it is 6 equals e natural log of 2 over 50 times t. How do I undo the natural log? I mean the e, natural log, I said it. So I get natural log of 6 equals natural log of 2 over 50 t. So what does t equal? Natural log of 6 over natural log of 2 times 50, which is about 129 years. That's not what they asked. Go back and read the question. What did they ask? What year? Do I have to add that to 1900? Do you see what I'm getting about y'all will do all the math correctly and then you won't answer the question they asked? Lose points. Okay, adding that together, do you get 2029?
C'est simple.
Yes? There's another example, but I think that's enough. Why don't you try that? We'll save that, and we'll do that again if, like, next week for the review day if you need it. But right now, because we've already worked these. We actually did it yesterday, and y'all didn't know it. Was it all the same math we did yesterday? Boy, did I trick y'all. Y'all were doing exponential growth and decay before we got to it. Now,